we will cover how to manipulate tables by adding, removing, and modifying elements, as well as using built-in table functions. You can add new elements to a table by directly assigning values to specific indices or by using the table insert function. In this example, we are adding an element to our table by using indices, and then we print the table using the built-in function table concat. The first line creates a table with 3 elements, 1, 2, and 3. Next line adds the value 4 at the 4th position of the table. Now, my table contains 1, 2, 3, and 4. The table concat function concatenates the elements of the table into a string, with each element separated by the specified delimiter, which in this case is a comma. So, the output will be 1, 2, 3, and 4. This example demonstrates how to add an element to a specific position in a table using indices and then print the table as a concatenated string using table concat. Instead of using indices, we can use a built-in function. By using table insert function, you can easily add elements to a table without having to manually manage indices, especially when you want to add elements at the end or in specific positions. This function call inserts the value 4 at the end of my table. If you want to insert the value at a specific position, you can provide a second argument specifying the position. By adding 2 as the second argument to the table insert function, we specify the position where the new value should be inserted. The third argument, 1.5, is the value to be inserted at that position. This allows us to easily insert elements at specific positions within the table without manually managing indices. We could use nil to remove an element from our table, but in this case, the table still has 4 elements, with one element being nil. When we use table concat, the presence of nil values can cause issues since table concat expects a sequence, meaning a table with no, nil, gaps between indices. When you want to remove an element from a table and maintain the integrity of the sequence, using table remove is the preferred approach. This function not only removes the specified element but also shifts all subsequent elements down by one position to fill the gap. This ensures that the table remains a proper sequence, which is important for functions like table concat that expect a contiguous array. You can modify existing elements by directly assigning new values to specific indices. When you use table sort function, Lua will sort the elements in ascending order. This works for numbers and strings, following their natural order, numerical for numbers and lexicographical for strings. You can provide a custom comparison function to change the sorting behavior. To sort the elements in descending order, you can provide a comparison function that returns true if the first element is greater than the second. Overall, understanding how to manipulate tables effectively is essential for writing clean and efficient Lua code, especially when dealing with complex data structures and algorithms. By mastering these techniques, you can harness the full power of Lua's table manipulation capabilities.